Hello and welcome. From previous task, I have not completed one part, and that is IPv6 address family. And like I said, I'm going to do this in two different ways. But before doing this, I want to show you that I have configured IPv6 router OSPF, which means that right now I have IGP enabled for this part for IPv6. Let me just show you the configuration so that if you want to do the configuration, you can do it with me. So if I just say show run, I'm just going to say show run because I'm going to show you everything, not just part of the configuration. Here you can see that in this part we have router IPv6 OSPF. I have not specified any instance ID. I just said router IPv6 OSPF. I have assigned the router ID. Router ID is the same as what you have on OSPF v2. That's an let's say a 32-bit router ID, which is going to be something like an IPv4 address. And under each one of the interfaces, I have just said IPv6 router OSPF area 0. If you do this, it's going to add instance 0 for you, so you don't have to go with this. And this is instance 0 because I have not assigned any instance ID to this. This means that this is going to be instance 0. And just to show you, I would say show IPv6 router OSPF, or show IPv6 OSPF, not router. And now you can see that it says the routing process is null, which means kind of 0, as a matter of fact, in this case. Okay, now what I'm trying to do is to add IPv6 address family to router BGP, and I'm going to do this in two different ways, like I said. One, using activation of the current neighbors that I have, and second, I'm going to create neighbor adjacencies using IPv6 addresses. So let's do this here. I'm going to go to router 8 and start from there. Router BGP 200, address family IPv6 unicast, and then I'm going to say, let me show run router BGP so that we have this easier. So I'm going to just activate these two under router 8. Okay. Now, what I'm going to do is to do the same thing on router 9, 10, and 11. So let's do this. And finally, I'm going to commit this on all of these routers. So configure terminal router BGP 200, address family IPv6 unicast, and then do show, or I can just paste this because both of them are the same in this case. Here I'm going to say show run router BGP, configure terminal router BGP 200, address family IPv6 unicast, and let's activate these two. And the same on router 11, configure terminal router BGP 200, address family IPv6 unicast. And these two, of course, are going to be activated here. Let's commit all of them at the same time. So I'm going to say commit. And now that I have set commit, I can just go with some verification commands. So previously, let's just end here, and we're just going to do this on all of the routers so that you can just save all of them at the same time. What I'm going to show you is another format of configuration. So if you say show IP BGP summary, it's going to give you IP adjacency, which is a BGP for IPv4, but no way we can do it for IPv6. But this format is going to be super simple for verification. You should say show BGP, not IP BGP. And after BGP, you should say IPv4, IPv6, whatever every address family that you can just think of. It is all of them are here. I'm going to say IPv6 in this case and unicast, and I'm going to say summary. Okay, so this is going to give me all the adjacencies for IPv6, and you can see that although it is showing me the IPv6 adjacencies, it's showing me the ID of IPv4 neighbors. That's okay, no problem. And if I just say show BGP IPv6 unicast, for now there is nothing in my BGP table because I have not advertised anything. Okay, so the task says I should advertise loopback interfaces using network command. I can do that, no problem. So what I'm going to do is to go back to configuration mode, go to router BGP 200 on all of the devices, and go to address family IPv6 unicast on all of these devices. Now on each one of them I'm going to advertise something using network command. So if I say network, and after that say 2000 : this one was 8/128, and hit enter, and I'm going to commit this. The same thing on router 9, 10, and 11. But before continuing, you should know something. This network has already been advertised into routing table by OSPF. And if I just show you running configuration of interface loopback, you can see that it says IPv6 router OSPF is here. So whatever IPv6 address I set on this, all of them are going to be advertised into OSPF. In this case, OSPF has better administrative distance than BGP. So these are going to be in routing table because of OSPF, not BGP. Let's see that. I have just committed this, so I should see that. Show IPv6 route and hit enter. You can see that 2000-8. This one, of course, is connected. Let's go to router 9 and check it on there. Do show IPv6 route. You can see that this is here because of OSPF, not BGP. And because I have multiple paths to get to there, ECMP is enabled by default for me. So because ECMP is by default enabled and it has a maximum path of 4. So that's okay. But what I'm trying to show you is, in some platforms, you get something which is called RIP failure. But here, RIP failure is not going to happen for you. Let's see. Show BGP IPv6 unicast and hit enter. Right now, it doesn't show anything. Let me see why. Do show BGP IPv6 unicast. Here we have this in our BGP table. Let's do this on all of the devices because I need to see them. There is a good reason that router 9 doesn't see that, and the reason is the split horizon rule, or the rule for IBGP advertisement. Let's just see that. Let's go to here and say network 2000 : 9/128 and commit this. On router 10 I'm going to do the same thing. Network 2000 : 10/128 and commit this. And on R11 the same thing. Network 2000 : 11/128 and then commit this. Okay, so on R11 if I say do show IP, or let's do it on all of the routers, that would be much better. So I'm going to say do show IPv6 BGP, do show BGP IPv6 unicast and hit enter. So router 11 knows about 8 and 9, it doesn't know about 10. The reason, like I said, BGP rules. Router 10 knows about 8 and 9, it doesn't know about 11. The same thing for router 9 and 8 are here. And you already know the explanation for that. You know that by rule, BGP advertises routes to IBGP neighbor in case it has received it from an EBGP neighbor. So if our router 8 has received something from R1, which is an EBGP neighbor, it would advertise it to R10 and R11. If R8 receives something from an IBGP neighbor, it will not advertise it to another IBGP neighbor. It will only advertise it to an EBGP neighbor. So that is the rule, and that is why you do not really see those routes, some of those routes into here. And the fix for that, of course, could be different. We can create a full mesh, which is going to be a little hard to manage, and scalability is an issue because after some time you do not really have the ability to add more links when the number of routers grow. And in some of the environments, believe me, it can grow up to thousands of routers. The next fix, which is much better, could be using route reflection and also confederation is another type of fix for this. So we are going to examine, of course, all of them during the tasks, but for now let's do something else. I'm going to remove this address family right now, and I'm going to create adjacencies using IPv6 addresses now. So let's go back to here. On all of these, I'm going to say no address family IPv6 unicast. So I'm just removing this on all of these. So it says there's an error because I need to exit and then do that. Okay, now I did it, and I'm going to commit that. Here I'm going to run address family IPv6 unicast one more time. Now let's do this. Under this, I'm going to say I am adjacent with router 10 and 11 from router 8, right? So instead of saying neighbor 10, 10, 10, 10, this time I'm using the actual IP address of the other side. So I'm going to say neighbor 2000, and I'm using loopback interface in this case, of course, 2010 remote AS, or remote, I should go out of course. Let's just exit. Neighbor, outside of the address family, I'm doing this, 2000, and that would be 10, double colon, of course, 10. That is in remote AS 200, and I'm using update source of, and I can again go with loopback 0 or use one of the IPv6 addresses which I have assigned to this. The second part is going to be much better. So I'm going to say 2000 double colon 8. The same thing for the other neighbor, which is 11. And update source of this. Now I'm going to go back to address family IPv6 unicast. I'm going to say these neighbors should be activated. So this one, activate. And this one is going to be activated. Now I can just add some networks as well. So let's say network 2000 double colon 8/128. I just added this. I'm going to commit this configuration. Let's do this on other routers as well. Let's go to router 9, exit address family. I'm going to say neighbor 2000. I can just copy from here and paste it. Why would I just do everything again? I just need to copy this commands because these are exactly similar on router 9. So I'm going to say this. Under address family, of course, I need to activate them. And also, I can just advertise a network, which is 2000 double colon 9/128. And then I'm going to commit the configuration. Let's do the same thing on router 10 and 11. So here I'm going to say exit address family. Under BGP, I would say neighbor 2000 double colon 8 is in remote AS 200 with update source of 2000 double colon. Oh, I needed to fix the update source on the other side. That was a mistake. I need to go back to do that. That's okay, no problem. Of 10. And let's do the same thing for 9. And update source for 9 is going to be this. And let's go to address family IPv6 unicast. Under this, I'm going to say this neighbor should be activated. And this neighbor should be activated. And I might want to advertise a network 2000 double colon 10/128. Okay, let's commit this and let's go back to router 9 and fix the problem that we had here. The update source should be corrected. So I'm going to say exit. Here I'm going to say this neighbor update source is 9 because I'm on router 9. And also 11 should be like this. And I'm going to commit this. And I'm going to say show run router BGP. Here, the update source is fixed, no problem. Nice. Let's go to router 11 and do the same thing here. So I'm going to just copy this, paste it on a notepad, and makes the necessary changes, which is going to be this and this. So I'm going to just take it and paste it on router 11. Exit address family, paste them here. And then I'm going to do this under here, address family IPv6 unicast, and paste it here. Now maybe a network is going to be advertised, which is this one. Okay, let's commit everything and now check everything. So end for all the routers, WR for all the routers, show BGP IPv6 unicast summary. Hit enter. Instead of seeing the IPv4 addresses in the neighbor, now you can see that I have this IPv6 addresses here. Let's just increase the width of the terminal. So I'm going to say terminal width is going to be 256. And then run the command one more time so that we have a neater, better visualization here. Okay, so I have this and I have sent and received a one prefix, as you can see. On all the routers there is the same thing. And if I just say show BGP IPv6 unicast, just to see the IPv6 prefixes which I have received, of course the same output is going to be there, but as I told you, there are some little differences that we can just check them here. Let me give you another verification command. So I'm going to say, as I was saying previous verification, I would say show BGP IP or BGP, let's say IPv4 unicast neighbor, for example, 10, 10, 10, 10, and it would say that there was address family IPv6 unicast enabled, but here you do not really see that. This is an extra adjacency right now. It is not the previous adjacency that we had with an extra capability. This is a totally different capability. So what I'm trying to say is, instead of IPv4, first of all, I should say IPv6, and after that, I should just mention the IPv6 address here for the neighbor. Here it says that address family IPv6 unicast capability is here. So it is a long task to finish, but I showed you two different ways. Which one is better? Based on the policies that you have, you can just choose one. I would prefer the second one, but again, you know that everything is based on the design that you have, not based on the good features or bad features that it provides, because there is no good and bad features. Everything is there just because you want to pick from them and add to your network. So this part is done, and I hope this has been informative for you, and see you in next video.